by taking the range. And now finally the distribution of range that we have discussed in general. Now in particular with this example, the distribution of range. So here range will be, because we have 5 observations, so in this case the range is going to be x5 minus x1, the largest and the smallest, or you can say y5 minus y1, and we take as v here y5, or the fifth order statistic, the largest one. Then the marginal distribution, as we had the form earlier, we have written the form of the range. H of r is n factorial upon n minus 2 factorial and integration of over v from r to infinity. This density also already we have derived. So again making all the substitution, n is 5, so 5 factorial upon 5 minus 2 factorial, that is 3 factorial. Then integration of over v from r to infinity. For capital F, we substitute the distribution function. So f of v is 1 minus e raised to minus theta v. F of v minus r will be 1 minus e raised to minus theta of v minus r, whole power n minus 2, n being 5, the power is 3, and small f of v minus r is the density of exponential, that is theta e raised to minus theta v minus r, and similarly f of v theta e raised to minus theta v and dv. So now simplifying this integration, right, some terms will get cancelled, and whatever terms they do not involve v, we can take them out of integration. So the terms which only consist of r and does not consist of v, that we have taken out of the integration, and so only it remains to integrate with respect to e raised to minus 5 theta v. So integration over v, that is only for e raised to minus 5 theta v. So solving this integration, our final form, our final distribution of range in this case is going to be 4 theta e raised to minus 4 theta r e raised to theta r minus 1 whole power 3. Now this way we can do it for any other distribution also, like if you want to find out the distributions of various order statistics in case of uniform distribution or any such other distribution, but provided the distribution should be continuous. Our assumption here is that the random variable under consideration should be the continuous one. Then similarly with these general forms we can do it for any distribution and any order statistic, or even we can find out a distribution of the joint distribution of any 2 order statistics, or even we can define the joint distribution of all the k order statistics. Thus what we have discussed in today's session is what is order statistic, what is the importance of order statistics, where order statistics is important. So as we said that order statistics may be in particular interested in some non-parametric inferences where we are concerned more with ranks rather than the magnitude or the values. Okay. Similarly, then we also discussed about how to, given the probability distribution of the original random variable under consideration, how to derive the distribution function and the density functions of our order statistics, any single order statistic. Similarly, we can also derive the joint distribution of any 2 order statistics, or even we can derive the joint distribution of all order statistics. And not only that, if not all order statistics or not just 2 order statistic, but if you want to derive the joint distribution of any 3 out of n, any 4 out of n, that is also possible. Then you can also derive that distribution. Similarly, many a times we may be interested in the range of the data also, that our data varies within which range. Then we can, it is also possible to derive the distribution of range. So this is what we have discussed today, that distribution of order statistic, joint distribution of 2 or joint distribution of all n order statistic, or distribution of range. And finally we took up one example for exponential distribution, and similarly one can also do it for any other continuous distribution also. Thank you.
SANDHAN. All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.